All right, well, welcome everyone to the Oakland Public Library's Let's Learn About Solar Eclipses talk. Tonight we have the wonderful Andrew Fracknoy, who is sometimes called the Bay Area's public astronomer. He is retired from the chair of astronomy at the Foothill College, but he still teaches introductory astronomy at the University of San Francisco and San Francisco State. He has published several books, including teaching manuals, science fiction based on good astronomy, and When the Sun Goes Dark, a book for children about eclipses. He is also the lead author of the most frequently used astronomy textbook, which is available free online through the OpenStax project. His contributions to the public appreciation of science has been recognized by the International Astronomical Union, to which they named asteroid 4859 asteroid Fracknoy. He appears regularly on local and national radio, explaining science developments, and we are so honored to have him here with us this evening at the Oakland Public Library. Thank you so much for being here, Professor.
Well, thank you for that nice introduction. I just ran out to put my cell phone elsewhere because I heard it jingling and we don't want to be interrupted for cosmic business here. Well, thank you so much. And thank you all of you who are tuning in either live or through the recording. I'm a great fan of public libraries, and I'm delighted that we astronomers this year are working with public libraries to make the eclipse more accessible to people nationwide, and I'll tell you more about that. Um, Let me begin now by sharing my screen, and let's see if we can get the screen up. Okay, great. So I'm here to tell you that there's not just one eclipse coming, but two in this school year. And I want to take you on a little tour of what's happening in the sky in 2023 and 2024. So it's rare that a country or a continent gets two eclipses in a row, but that's what's happening. This Saturday, October 14th, we're going to get a ring eclipse, an annular eclipse, and then next April, we're going to get a total eclipse crossing the United States and North America. So we'll talk about each of these in turn, but let's begin with what an eclipse of the sun is about. Many people don't know that a remarkable coincidence is true in our skies. As seen from Earth, the moon and the sun are the same size in the sky. Now, the sun's a lot bigger, but it's far away. The moon's a lot smaller, but it's close. And it just works out that the two happen to be about the same size. We've calculated actually that this is not true for any other planet. If you don't believe me, here's an example. This is a series of pictures taken from the surface of the planet Mars. What you're seeing is one of the little moons of Mars crossing the sun, doing its best to cause an eclipse, and being totally pathetic at it. The moon is just not big enough to cover the sun, and there's not much of an eclipse. But from Earth, the coincidence works. So what happens when the moon exactly covers the sun? Well, a spectacular view becomes available. You see the faint atmosphere of the sun, which is always way too faint to see under normal circumstances when the sun is out. Suddenly that becomes visible. We see activity, flames, if you will, arches of hot material on the side of the sun. The day becomes night. This is when there's an exact cover-up of the sun by the moon. We call that a total eclipse. Now, here's the geometry of what happens during an eclipse of the sun. The moon gets in front of the sun, and a shadow is cast by the moon, and the shadow makes a dark spot on the Earth. If you're inside the dark spot, you see the total eclipse. If you're outside the dark spot, you may only see some of the sun eclipse, what we call a partial eclipse. And then because the moon moves and the Earth turns, this dark spot moves across the surface of the Earth, and more people can share in the splendor of the eclipse. There are three types of eclipses that can happen. I've been talking about a total eclipse when the sun is completely hidden by the moon. As I said, that's only true when you're in the dark shadow. Sometimes, though, the moon is a little too far away. The moon's orbit is not a circle. It's more of an oval shape. And if this alignment of the sun and the moon happens when the moon is more distant in its orbit, when it's on the more distant part of its orbit, then the moon is too small to cover the sun, and it leaves a ring around its dark disk. That's called a ring eclipse, or another word for ring is annulus. So this is the annular eclipse, and that's what we're having Saturday. And then if you're not exactly in the dark spot, if you're some distance away, you see only part of the sun covered, and that's called a partial eclipse. That's the geometry. Now let's look at the actual pictures. So during the total eclipse, you see the beautiful faint atmosphere of the sun here. During the annular eclipse, the sun is still out. You see a ring of fire around the moon. And then during the partial eclipse, you see a big bite taken out of the sun. So here is an actual picture from space showing you that dark spot, that dark shadow when the sun is eclipsed inside that dark area. So just in case you were doubting that this actually shows up on the surface of the Earth, this dark spot, there is a space picture to document that. And as the moon covers the sun, you often get this beautiful diamond ring effect where the last little mountain on the moon allows a little bit of sunlight through, and you get this last glimpse of the light of the sun. All right, but let's now get down to exactly what's going to happen. Let's start with October 14th, this Saturday. We are calling it the American West Ring of Fire eclipse because it's especially good in some of the Western states. So this is the sequence of events. The moon begins to cover the sun. More and more of the sun is covered. And then when the eclipse is at its maximum, you get a ring of fire effect. You get the annular eclipse. Where will that annular eclipse be visible this Saturday? Well, here is the path. The shaded in region is the path where the eclipse will look like a ring. Turns out it starts here on the coast of Oregon, goes across Utah, New Mexico, actually goes through Albuquerque, which is having a big festival, parts of Texas, out into the Gulf of Mexico and down to Central America. So you see here in San Francisco, we're not in the ring path, but we are going to get a substantial partial eclipse, which I'll talk about. So throughout the United States, every state will see a partial eclipse. The same will be true in Central America as well. Everyone will see a partial eclipse. Where will the 2023 eclipse be a ring? Where will it be annular? I mentioned Eugene, Oregon, Winnemucca, Nevada, Albuquerque, New Mexico, Roswell, New Mexico, the UFO capital of the universe, will also have a ring effect. San Antonio, Texas, at least parts of it, and then down, as I said, into Central America. That's where you can see the ring effect. Here in Oregon, for example, I mentioned it won't be everywhere in Oregon, but Eugene is included in the path. This region which is shaded is the path, but Portland isn't. So if you're in Portland, you'll just see a partial eclipse like we do in San Francisco. But as you go into the ring region, you'll see a ring type eclipse in Coos Bay, in Eugene, Roseburg, etc. Now, one important question for any eclipse viewer is, what's the weather likely to be? So people have gone and looked at what October 14th looks like historically in terms of cloud cover. And this graph shows you the chances of the clouds covering the sky. So 0.5 means 50-50, 50-50 chance of cloud cover or clear. If it's 0.3, then it's a 30% chance of cloud cover, 70% chance of clear. And you can see that up here in Eugene, it's like almost 70% chance of cloud cover. So that's not great. But as you go further toward the east, you begin to see that things get better in terms of the likelihood of clouds, and Albuquerque is down below 30%. Roswell is down below 30%. So that's why a lot of eclipse chasers are gathering in these states, because not only is it a good place to see the ring, but also the chances of clouds are lower there than anywhere else. All right. What will the eclipse look like in major US cities on Saturday? You can see that in New York City, for example, 35% of the sun's diameter will be covered. Here in San Francisco, 83% of the sun's diameter will be covered. So we're doing a lot better than New York in terms of the size of the bite being taken out of the sun. In Washington, D.C., the cover up will be about 42%. And that's pretty typical of the cover up in Washington, D.C. No, I didn't say that. That's a political remark. This is a public library, no politics. All right, moving on. What will we see in San Francisco? As I said, 83% of the, and San Francisco includes Oakland and the Bay Area, I mean, in the Bay Area, 83% of the sun's diameter will be covered by the sun. That's a very substantial bite. The eclipse begins at 8 in the morning, 8:05, but you don't see much at 8:05. That's when the moon begins to cover the sun. It slowly moves across the sun, taking more than an hour, and the biggest bite is taken at 9:20 a.m. So unless you're absolutely a rabid eclipse fan, you don't need to get up at 8, because the eclipse will be especially good when it's the biggest bite. So I'd start watching at 9, and you still have lots of time to see the sun with a big bite taken out of it. The eclipse ends, the moon moves off the sun at 10:42 a.m. So that's I intend to be watching from about 9 to 9:30, and that's fine. That'll be plenty. Um, but now think about these times. 8 in the morning, sunrise is a little after 7 these days. So at 8 in the morning, the sun's not so high. The sun rises in the east, and an hour later, the sun is still kind of toward the eastern horizon. It'll be a little higher by 9:20, but still toward the east, not overhead. So if you're looking for a place to observe the eclipse with your family on Saturday, it'll be really important that it have a view toward the eastern horizon and not some giant hill or mountain obstructing your view toward the east. So I would check this out on Thursday or Friday in the morning. Can you see the sun at the times you intend to look? At 9 in the morning, where you're standing, can you see the sun? If you can see the sun on Friday, you'll be able to see the eclipse sun on Saturday. But just be mindful of needing a view toward the east. All right, now we'll talk about how to view the eclipse in a minute, but if you are not able to find ways to view the eclipse for yourself, or you want to join in with other people, there will be eclipse parties in several Bay Area locations. And so Saturday morning, you can go to some of these eclipse parties and join with other people, get special eclipse glasses if you haven't already gotten some, and be part of the eclipse excitement. Among the places you can go are Stanford University, the Chabot Science and Space Center in the Oakland Hills, the Exploratorium Science Museum in San Francisco, Foothill College in Los Altos, which has an observatory. And we've put together a short URL for the page where you can see all the details of where these are going to be. And that's bit.ly/Bay Area Eclipse. So I'm going to ask our host to put that in the chat in a minute. So if you didn't get a chance to write it down, it will be in the chat. Bit.ly Bay Area Eclipse. That's still being updated, and that's where the eclipse parties can be joined. All right, now suppose you have friends or relatives in other parts of the country who are not aware that this is happening, and you call them tonight and say, hey, I just heard this astronomer with a weird name talking at the Oakland Public Library. Everyone's going to see an eclipse. Do you know about this? And they say, well, we didn't know about it. What's the eclipse going to be like in our town? You might say, well, I don't know. I didn't quite catch what it's like in other places. Here's the way to find out. You go to a website called timeanddate.com. It's a wonderful website with all kinds of things about time and sunsets and things like that. If you go to timeanddate.com/eclipse, you can look up what an eclipse is like for any eclipse in the next dozen years. And you can put in your town, your community, and up will come what the eclipse will be like in your community in local time. So if you put in Washington, D.C., the website will give you the local time for the different parts of the eclipse and how much of an eclipse it'll be for Washington, D.C. So this is the website to share with your friends and relatives if they want to know what the eclipse is like. Just put in first the October 14th eclipse, put in your community, and it will tell you what you need to know. All right, that's the story for Saturday. But for many people, Saturday is just the appetizer. And the main course is coming in April. On April 8th, 2024, which is a Monday, so for many people, it will be a school day and a work day, there will be a total eclipse crossing the United States. And not just the US, but also Mexico and Canada. So we're calling it the Great North American Total Solar Eclipse, April 8th, 2024. Here's the sequence of events during a total eclipse. Again, the moon is covering the sun. More and more of the sun is covered. The last little bit of the sun goes out, and then day turns into night. The stars even come out. It's not totally dark, but some bright stars or planets come out. The sun completely is covered by the moon. The faint atmosphere of the sun becomes visible. And for many people, this is a once in a lifetime experience. It lasts about 4 minutes. So you need to really take it in. And then the moon moves off the sun. More and more the sun is uncovered and the normal day returns. That's the sequence of events during a total eclipse. Now, again, just like the annular eclipse, you have to be in a certain narrow path to witness the total eclipse. Everyone will see a partial eclipse, but only people within the purple lines will see the total eclipse in April. And you can see the total eclipse enters the United States in Texas, goes through some or near some pretty big towns in Texas, like Austin and Dallas, moves upward into the Midwest, goes through Indianapolis, for example, and goes into upstate New York. In fact, the eclipse will be total in Niagara Falls. You can just imagine the weddings that are already being planned for April in Niagara Falls, and then moves into New England and Eastern Canada. If you are within the purple lines, you will see a total eclipse of the sun. Outside, you will see a partial eclipse. The closer you are to the purple path, the more of the sun will be covered in your partial eclipse. You can see that this is a pretty busy corridor that the eclipse goes through. We estimate 32 million people live within the purple line. And that's a lot of people to be able to see a total eclipse of the sun. If you have relatives who live in this purple zone, now's the time to call them and tell them how much you miss them and how you'd love to visit in April. Many national parks are within the two eclipse paths. There's a website called greatamericaneclipse.com, which is put together by a map maker, a professional map maker, and he has maps of everything you'd possibly imagine. And I like this map, which shows all the different national parks you could reserve a spot in if you want to see either the Ring of Fire eclipse or the total eclipse. A little late now for Saturday, but for next April, you can still get a spot if you want to be inside the eclipse zone. Where will the 2024 April eclipse be total? Well, I mentioned some of these already, near Dallas, near Little Rock, Arkansas, Indianapolis, Cleveland, Niagara Falls, Buffalo and Rochester, New York, both big towns, then parts of Canada, and so on. That's the kind of community you need to be in to see the total eclipse. The problem is weather. The further north you are, weather experts tell us, the more likely it will be cloudy. And so, as you're thinking about if you want to go and see the total eclipse, what you need to plan for, you need to plan for the weather. Here's another one of those nerdy charts that shows you the likelihood that the sky will be covered with clouds. 1 would be 100% chance that it'll be cloudy. 7 means 70% chance it'll be cloudy. And the further down you are, the more likely it is to be clear. So Mexico, which we haven't talked about, actually starts in Mexico. Mexico is the most likely to be clear. Texas is about 50%. That's why many people are going. If you're going to be in the United States, Texas is the best place to be in terms of the likelihood of clouds. And then the further north you go and the further east you go, with some dips, it's going to be likely cloudy. Here in, for example, Plattsburgh, we have a 70% chance of cloudiness. Cleveland, it's about a 58% chance of cloudiness. So many people are taking the weather into consideration as they plan. Again, you can get maps at this site called thegreatamericaneclipse.com. You can get detailed maps of every state. Here, for example, is Austin, and the path is shown here with yellow borders. And it turns out, this is just something for the people who are really serious, that the closer to the middle of the path you are, the longer the eclipse lasts. So people who want the most eclipse experience don't just make sure they're in the path, they make sure they're in the middle of the path. So for example, in Austin, in main parts of Austin, you might only get 2.5 minutes if you're in Austin. But if you go a little bit north of Austin, you can get 4.5 minutes of eclipse. So those who are serious about appreciating the beauty of the total eclipse, make sure not only that they're in the path, but that they're in the middle of the path. And again, if you want maps like that, go to greatamericaneclipse.com. That's, again, here it is, the Great American Eclipse website. Michael Zeiler is a wonderful map maker, and he does this as a public service, greatamericaneclipse.com. What will the eclipse be like in major US cities? Well, you can see it's a little bit different from October. In April, New York will be the one with the big bite taken out of it, and San Francisco will have less than half covered. We'll have a 45% bite, whereas New York will have a 91% bite. Houston will have a 94% bite. Washington will have 89%. So if you want a bigger bite taken out of the sun, you got to get closer to the eclipse path. What will it be like in the Bay Area on April 8th? As I said, about 45% of the sun's diameter will be covered. It's a little bit later in the day. The eclipse begins 10:14 a.m. on April 8th. The maximum eclipse will be 11:13. So now we're getting closer to noon. The sun will be higher in the sky. And the eclipse ends by 12:16 p.m. on April 8th. So this will be a less dramatic partial eclipse for us in April. Now, who will see some kind of eclipse in these two times? We calculate 500 million people will see at least a partial eclipse. And this is a typical astronomy teacher thinking about that number. Oh my God. 500 million people will have the opportunity to observe the eclipse, but they all need to be educated. Oh my goodness, what are we going to do? We had some of the same problem in 2017. Some of you may remember that in 2017, an eclipse crossed the United States and got a lot of publicity. And the problem is, whenever any part of the sun is showing, it's not safe to look at the sun with unprotected eyes. Even if a good part of the sun is covered, the rest of the sun is bright enough to hurt your eyes if you stare at it without proper protection. So what we need are special protective glasses. In 2017, even kids were aware of the importance of these glasses. I'm joking, of course, and made sure that they watched the eclipse safely. And not all adults were aware. Some people just didn't get the message and looked with their eyes, but not for long. Um, so if we have 500 million people eligible for eclipse viewing, we will need a lot of safe solar viewing glasses and a lot of information getting out to the public. We astronomers said to ourselves, what are we going to do? And we realized that many communities have a built-in information distribution center already, which is the public library, a wonderful institution. And so we talked to a foundation that was interested in science and asked, would it be possible for us to enlist public libraries as our secret agents for eclipse education? And we also talked to the libraries and the American Library Association, and everyone seemed enthusiastic. We tried an experiment in 2017, but this year we're going big time. And so the Gordon and Betty Moore Foundation, right here in the Bay Area, I am pleased to say, working through the Space Science Institute in Boulder, Colorado, is distributing 6 million eclipse glasses free of charge through 13,000 public libraries nationwide. And this program has been going on. The libraries have received their glasses and have really distributed many of those glasses. The Oakland Library is part of this project. So if a library is not yet participating, wants to participate for April, they can go to bit.ly glasses for libraries, but we don't need to worry about it because the Oakland Library is participating. In addition, we've provided the libraries with a little booklet all about how to understand and watch the eclipse safely. I'm one of the co-authors of this booklet. And if you want to see this booklet even without going to your library, you can just go to bit.ly/eclipses for libraries. And if one of our hosts could put that in the chat too, http bit.ly eclipses for libraries. That's the booklet that has a lot of the information I'm covering tonight in it in a nice, easy to understand format. Bit.ly eclipses for libraries. You heard I'm one of the authors of a children's book published by the nonprofit National Science Teaching Association Press. If you have kids or grandkids who might be interested in what exactly this eclipse is about and how to understand it, we've put this book together called When the Sun Goes Dark. And in it, it not only has pictorial explanations, but it suggests some activities that families can do together with safe home materials that will help kids really understand what's happening with shadows and darkness and light during the eclipse. So if you're interested in really explaining all this to kids, this might be a useful book for you to have. It's available through Amazon and through many booksellers. When the Sun Goes Dark. You can see in it there are things you can do like hold tennis balls with an uncovered lamp to simulate the light and dark patterns that are part of eclipses. All right, for those who are teachers, we've also put together a book of classroom activities revolving around the sun, the moon, and eclipses. It's called Solar Science, also from this nonprofit NSTA Press, Solar Science for Teachers. In addition, the foundation, the Gordon and Betty Moore Foundation, are funding 275 science teachers to be agents in their communities to help people understand the eclipses better. And these agents are already hard at work around the country, setting up eclipse events, talking to their students, to the families, to communities about the 2 eclipses that are coming. We've put together a booklet for teachers, but you don't need to worry about that. And I do want to mention one other thing. I don't make any money from this, but some people are really interested in this. Many people have tried to photograph an eclipse with their cell phone camera and have completely struck out. The partially eclipsed sun is too bright for your cell phone camera. Just like you shouldn't look at the sun directly when it's not totally eclipsed, so you should look at it through your cell phone directly. But astronomer Douglas Duncan at the University of Colorado has invented something called Solar Snap, the Eclipse app, which is a filter that you can snap onto your cell phone camera, and an app that you can download onto your camera, and that lets you take safe and effective photos of the eclipse through your cell phone. So you can go and see if it's still available in places like the Exploratorium or science stores, or if you have enough time before April, you might want to get that. You can order it just by Googling Solar Snap or going to the place where the glasses are available, American Paper Optics. And again, this is not a commercial. I don't make any money from it, but it's an invention we've never had before, which is a safe way to use your cell phone. And it's called Solar Snap. All right, and you can get really amazing pictures, particularly in urban environments, of the partially eclipsed sun when you have proper filters. Don't look through a camera at the sun without the proper filter. But if you are able to filter your camera, then you can take remarkable pictures. One of the things we're warning people about is if you go to where the eclipse is total, be prepared for a lot of traffic. A lot of people will be going into the eclipse zone, some of them at the last minute as the media alert people that the eclipses are coming. So it's really important for towns to plan ahead and have facilities available for the big crowds that may show up. This was a problem in 2017. And this is not the first time we've had to worry about it. Here, just for fun, is a headline from 1918, when again there was an eclipse of the sun that crossed the United States. And look at the headlines: thousands point glasses at the sun to watch eclipse. So we're not the first generation to think about, plan for, and enjoy eclipses of the sun. My main suggestion, particularly if you're now thinking about going to where the eclipse will be total in April, is to plan ahead. People who plan ahead do much better than people who wait till the last minute. If you can get glasses from your library, that's great. If you can't, we'll talk now about ways to observe the eclipse without those glasses. And if you go to the library and the glasses are gone this close to the eclipse, please be nice to your librarian. The librarians have tried their best to make sure that all the glasses they get to people who are going to use them and enjoy the eclipse. And even though we have 6 million glasses for the country, you can look at the 500 million versus 6 million and understand that most libraries are running out or will run out very quickly. So if by the time you go to your library and they don't have any glasses left, please understand that the librarians are doing their best and don't get mad at them. What I'm going to talk to you about now is how to observe the eclipse if you didn't get a pair of these safe viewing glasses. An easy way is to get a hand mirror. Take a hand mirror and cover most of it pretty securely with cardboard. And then in that cardboard, cut a little hole a little bit smaller than a dime. That's so that we just get a little bit of light. Take that mirror and angle it in such a way that you catch the sun's light, and you can then project it onto a wall. Let's see if I can do a diagram here. So you have the covered mirror, and you have a wall or screen. You kind of angle your mirror that you catch the sun's light where the hole is, and then project an image some distance away. The further away you project the image, the bigger it will be. Some people set up their mirror with a stand and then have a screen so they don't have to hold the mirror in their hands. Now, this takes some practice. If you put this together for Saturday without any practice, chances are it's going to take you a while to get it right. So my suggestion is if you are going to do this, use a handheld mirror, practice before Saturday so you get good at it. And then on Saturday, you could be the hero of your neighborhood, where this little mirror suddenly makes an image of the eclipse sun available safely to anyone who wants to watch it. This image on the wall or screen is perfectly safe to look at, and it's a way to share the eclipse with anyone who passes by or friends and neighbors you've invited. A simpler and smaller way to do this is just to use a pinhole. Take a piece of cardboard, maybe with an aluminum foil center, so you can make a very sharp pinhole in that aluminum foil. Hold the cardboard so that your back is to the sun and that the sunlight is going through the hole, and then let an image of the sun fall to the ground or to a wall, and that image will be small, but it will show you the eclipse sun. This is, again, don't look through the pinhole at the sun. That's dangerous. Hold the pinhole with your back to the sun so that you can project an image through the pinhole somewhere else. That's not as good an image as with the handheld mirror, but it still shows an image of the sun. Now, if all this sounds complicated, just forget it, because there's something in your house that will let you make a really spectacular eclipse demonstration without you having to do any construction whatsoever. And that's a colander. You know what a colander is, right? It's what you wash pasta or vegetables in. If you take an ordinary household colander, it has a number of holes in it. Each one of those holes is like a pinhole projector. If you now stand with your back to the sun, holding the colander over your shoulder, again, you're not looking at the sun, you have your back to the sun, you hold the colander so that the sun's rays come through it, and then project that onto a wall or a sidewalk, you will get a shadow which shows many pictures of the eclipse sun. As the eclipse grows, more and more of the sun will be covered by the moon in these pinhole images. And if you're out in the street holding a colander over your shoulder with other people around you, I bet that every pedestrian, every neighbor will come out and say, "What are you doing? Why do you have a colander on your shoulder?" And you can explain that you are sharing pinhole views of the eclipse with the neighborhood. It'll make you friends for life. All right. You can also, if you know a lot more about binoculars, you can use one part of a binocular and then project an image through the binoculars, cover the other hole. And those projected images from a pair of binoculars will also be safe to look at. But again, a colander is so much easier than any of these methods. All these methods, by the way, are in the booklet, bit.ly/eclipses for libraries. They're all explained much more slowly than I'm doing here in the booklet. If you want to know more about eclipse safety, the American Astronomical Society, the professional group of astronomers, does have an eclipse website with authoritative information. For example, in 2017, Amazon suddenly, without warning, flooded the market with eclipse glasses made in China that were not certified to be safe. And this was a big problem, and people had to be warned that they needed to check their glasses. This year, we astronomers are working with Amazon to see that that doesn't happen. But if you want to know what's the latest in eclipse safety, eclipse.aas.org can tell you more about it. If you're a responsible person in a school or a scout group, this is your reliable source for eclipse safety information. Now, people often ask, and we're almost done, I'm ready for questions soon, but people often ask, wait a minute, I may not be an astronomer, but I know what the moon does for a living. The moon goes around the sun. I'm sorry, it goes around the earth. The moon goes around the earth. That's why we call it a moon. And so every month, the moon takes a complete orbit around the earth. Why don't we get an eclipse every month when the moon and the sun are in the same part of the sky as seen from Earth? And it turns out there's a good answer to that. We don't get an eclipse every month because when the moon formed, its orbital plane, its orbit was tilted relative to how the sun goes around the earth, or more particularly, how the earth goes around the sun. Our orbit around the sun and the moon's orbit around us are actually two orbits that are tilted by about 5 degrees. So most of the time, when the moon and the sun are in the same part of the sky, the two bodies are not aligned because of this tilt of the orbit. The moon is either above the sun and therefore not eclipsing it, or below the sun in the sky and not eclipsing it. Only when the two orbits cross, when our orbit around the sun, or how we see the sun in the sky, crosses with how we see the moon in the sky, only when those two orbits are actually crossing do we get an eclipse. And that's every 6 months or so. It's not, the way to imagine this is, imagine you have two hula hoops. Your head is the earth. One hula hoop is the sun moving around us in the sky. The other is the moon moving around us in the sky. Most of the time, the sun and the moon are not together and they can't eclipse. But when the two cross, right where the student's hands are, where the two orbits cross, that's when you can get eclipse season. That's when it's possible to have an eclipse. And it turns out we get an eclipse season every 6 months or so. Somewhere in the world, every 6 months or so, eclipses are possible. But it could be anywhere in the world that that little spot of darkness falls. And the world is large. Most of the Earth's surface is water. So most eclipses don't happen where people are living. If you're an eclipse enthusiast, you might need to fly a plane or take a boat to a remote part of the Earth to see the eclipse that season. So you can look up on various websites when eclipses are coming. I show you here the eclipse seasons for the last few years. You can see it's about 6 months apart. Sometimes we get a partial eclipse of the sun and a total eclipse of the moon. Sometimes we get a total eclipse of the sun and a partial eclipse of the moon. But every 6 months or so, it's eclipse season somewhere on Earth. And eclipse enthusiasts follow these eclipse seasons and try to get to where the eclipses are. Well, eclipses have been of interest in human culture since we have records. And there are many legends and myths about eclipses. For example, in many parts of Asia, when an eclipse happens, the legend is that there's a dragon in the sky that swallows the sun. And this is, of course, a great danger to the community. You need the sun for agriculture, for life, for light, for heat. What are we going to do with this terrible dragon? And legend has it that the dragon is very sensitive to sound. So if you go outside and bang pots and pans together and make a lot of clanging noise, it will frighten the dragon and it will drop the sun and let the sunlight come out again. So during every eclipse in parts of Asia, there's a great tradition of making a lot of noise with pots and pans and whatever you can and frightening the dragon. And you know what? It always works. The sun is freed and we live another day. So I'm not recommending that you make noise, but we appreciate the fact that human cultures for many years have understood that eclipses are a dramatic part of what we see in the sky. What have we learned during these eclipses? Well, I mentioned that during an eclipse, we can see the atmosphere of the sun, which we don't normally see. So we astronomers have learned a lot about the atmosphere of the sun, the many layers that make up the outer part of the sun when eclipses allow us a glimpse of these layers. And I'll just mention that Albert Einstein was a great fan of eclipses because his most amazing theory, the general theory of relativity, was actually proven during eclipses. In 1919, an eclipse of the sun, which was visible off the coast of Africa, the stars came out during the total eclipse. And Einstein had predicted that because of his theory of relativity, the stars would be out of place. And by gum, they were out of place just as Einstein had predicted. So this is when Einstein became world famous during an eclipse in 1919, and he always remembered eclipses fondly as a way to prove his most dramatic theory. Well, let me finish up by mentioning that the next total eclipse to cross the United States will be in 2045, on August 12th, 2045. Old folks like me don't expect to see that in 2045. That's how long you'll have to wait if you want an eclipse crossing our country again. So don't miss the ones that are coming up in 23 and 24 because you'll have a long wait if you do. I hope I've given you some interesting things to chew on during this lecture. And I will finish by saying that I wish you clear skies and good observing for both these eclipses. Thank you. Thank you very much. And I'm happy to take questions at this point.